and the Parent Teen Cell Phone Survey conducted by Princeton Survey Research Associates International, 800 randomly sampled 16 to 17-year-olds living in the United States were asked whether they have ever used their cell phone to text while driving. Of the 800 teenagers surveyed, 272 indicated that they text while driving. Obtain a 95% confidence interval for the proportion of 16 to 17-year-olds who text while driving. And then if 1,000 samples of cells, 800 were taken, blank of the intervals contain P. Okay, so first we need our sample proportion P hat. That's 272 over 800. And if we do that out, that gives us a value of 0.34. And for our assumptions for us to do this confidence interval, we need that simple random sample, which this is. We need to take the sample size times the sample proportion. So 800 times 0.34. If we do that multiplication out, we get 272. And likewise, we need the sample size times 1 minus the sample proportion. And that will be 800 times 0.66. If we do that multiplication out, we get ourselves a value of 528. And then lastly, we need to make sure that the population size is greater than or equal to 20 times the sample size, in this case of 800. That gives us 16,000. And I'm pretty sure there are more than 16,000 16 to 17-year-olds in the United States. So that's fine as well. So now, based upon this, we need a critical z-score. This is going to be the probability that z is greater than or equal to some number is equal to, we want 95% confidence. We want 95% confidence. So because of that, we'll take 100 minus 95, so 5%. But divide that, we want to take that to be, we want this to be equal to, when we take the probability of z being greater than or equal to some number, we want this to equal to 0.025. And the reason why we want that is because the 95% confidence interval refers to all of this area between these two lines. We are only referring, though, to this part up here, to the right of it. So everything to the left of it, then, is going to be 9.975, due to the fact that this area to the right is 0.025. So basically, we took the remaining portion of this, which was 5%, and cut that in half. So that's the same thing as finding the z-score of sub 0.025, which is what we did here. If we put that into Excel, we would need to do norm dot s dot inv of 0.975. And if we put that into Excel, we get a value of about 1.96. We also need the standard error, which is just a fancy schmancy talk for the estimation of the standard deviation. We're going to take 0.34. Well, I should probably write out the equation first. That'll be the sample proportion times 1 minus the sample proportion divided by n. And we take the square root of that. So square root of 0.34 times 0.66 divided by 800. And if you do that out, you get a value of about 0.016748. And now to get this confidence interval, the confidence interval is for this is defined as p hat plus or minus that critical z-value times the standard error. Okay? And we could certainly do this here on on Excel as well. So let me open that up. I have this preloaded as a template, but for this we are going to put the characteristic value of 272. Sample size was 800, and our level of confidence was 0.95. We could see we have the sample proportion of 0.34. Z-score rounds to about 1.96. Our standard error is 0.016748. Margin of error, which is all of this. So the critical z-value times the standard error. That's our margin of error. And the two bounds for the confidence interval, 0.3072 and 0.3728. And then I also have the assumptions down here on the bottom. This first one checks that n times the times p hat to get 272. That's greater than 15. And then n times 1 minus p hat to get 528. Also greater than 15. Both of those are met. And then for 20 times the sample size, we get 16,000. And the population size is certainly greater than that. So to put our bounds in here, the lower bound for that was 0.307717. That's the lower bound. Lower bound. And the upper bound was 0.3728. And again, in my template, that was displayed in both of these here to the right. But now we want the interpretation of this. So interpretation of this interval is that at a 95% level of confidence, the percentage of 16 to 17-year-olds in the United States who text while driving is between 0.30717 and 0.3728. And then for the, if 1000 samples of size 800 were taken, blank of the intervals contain P. For that, the only calculation that we need to do for this is to do a confidence interval of 95%. So 0.95 times 1000. That gives us 950. So in this case, 950 of those 1000 samples will contain the population proportion P.